we're going to factor by grouping today. And so what I want you to notice is that when we're factoring, and you notice that we have 4 terms, I want you to immediately go to grouping. And so what that means is that we're going to group our first 2 terms together and our second 2 terms together, and we're going to find a common factor. Once we do that, you'll see kind of how that fits, and we can separate them out. The other thing we're going to do is find the roots, or find the zeros, or where, if we were to graph this, where it would cross the x-axis. Now this has up to 3 roots because its highest exponent is a 3. So let's go ahead and group these. So our first 2, we have 3x to the third plus 2x squared. I'm only going to look at this first group and find the greatest common factor. Well, 3 and 2 have a common factor of 1, so we don't have to worry about that. But if I have 3 x's here and 2 x's here, the most that I can take out is going to be 2 x's without going over, right? So I'm going to factor out an x squared. What that's going to leave me with on the inside of my parentheses is 3x to the first plus 2. And so just to quickly check to make sure that we did this right, if I go ahead and kind of in my head distribute this, x squared times 3x should give me back to 3x to the third. X squared times 2 should get me back to 2x squared. And notice, other than 1, there's no other common factor they can have. So we did this first part correctly. Now, the challenge can be is when they're separated by a minus sign. So if we're separated by a minus sign with the second group, you need to factor out that negative. So if your third term is negative, you need to factor that out. So what this looks like is the largest number that goes both into 12 and 8 is 4. So I'm going to factor out a negative 4. And be careful, when you're dividing by a negative, you have to be careful with the sign. So this negative 12x divided by this negative 4 is going to give me a positive 3x. And again, a quick check, negative 4 times 3x does get me back to that negative 12x. So we know we're doing that right so far. And then finally, a negative 8 divided by a negative 4 gives me a positive 2. And again, a quick check, negative 4 times 2 does get me back to negative 8, so we did this right. Also, if you noticed, on the inside of our 2 parentheses, we have the same expression here. We have 3x plus 2. Therefore, that's a pretty good indicator that we did something right. So this is a good news, and we can continue to move on. So what we're going to do is we're going to take the factor that they have in common, and we're going to bring that straight down. So 3x plus 2. What that leaves us with are these 2 terms right here that are going to then become their own factor in their own set of parentheses. And so we have x squared minus 4. And so again, these are multiplication problems. If we were to go back through and distribute all this, we would get back to our original function. Now, once we have our 2 factors set, what we can do is set each factor equal to 0 and then find the roots. So in terms of what we're doing in class, this is good enough in the sense of factor by grouping. We're going to talk soon about difference of 2 squares. Maybe you already have heard of that. And so difference of 2 squares, we could technically say that this is x plus 2 times x minus 2. So you have one positive, one negative, because a positive times a negative gets you back to that negative. X times x gets you back to the x squared, and then 2 times 2 gets you back to 4. So really a better answer would be what we have here in our 3 factors. Now, part of why we have 3 factors is because we're going to have 3 roots, right? If we would have solved this, you would take the square root of both sides. And when you take the square root of both sides, you have the positive and the negative value. So you'd get that plus or minus. So what we're going to do now, so this is our final answer in terms of factor by grouping. But we're going to take each set of parentheses, or each factor, and set it equal to 0 individually and solve. So I have x plus 2 equals 0, x minus 2 equals 0, and then 3x plus 2 equals 0. From here, we're going to subtract 2 from both sides, so we get that x equals the negative 2. Here we're going to add 2, so x equals positive 2. And here, after I subtract 2, I get that 3x equals negative 2. And after I divide both sides by 3, we're going to get that x also equals negative 2 over 3. So there's 1, 2, three factors or three roots given our factored form. What we're going to move toward is I'm going to give you these roots, and you have to work backward and get back to your original polynomial. So a degree of 3, 3 roots. All right, let's go ahead and go to number 2. So in number 2, notice that we have an x squared and then x to the third and then a 4 and then an x. This is not in standard form, so what you're going to want to do is rewrite this in standard form. So my highest exponent is 2x to the third is going to come first, then my x squared, then my x, and then my constant. Now that you're in standard form, now you can factor by grouping. So I'm going to look at the first two terms. Greatest common factor is x squared. So I have 2x plus 1. Remember, anything divided by itself is 1. And a quick check, x squared times 2x gets me back to 2x to the third. X squared times 1 is x squared. So we know we've done that right. Notice how this is a plus sign, so that's good. We don't have to worry about factoring out a negative. And so we want to see that third term be positive. It just makes it a little bit easier. Greatest common factor between 8x and a 4 is going to be positive 4. So once I take out a 4 from each term, I would get 2x plus 1. How we know we did this right, or a good hint, clue for us, is that what is inside the parentheses match. All right, so the two terms outside of your parentheses, those that you factored out, that is going to become their own set of parentheses. So x squared plus 4 times 2x plus 1. Now this is the correct answer, and some of you might be thinking, hold on, no, that's difference of two squares. Remember, there's difference of two squares being separated by a minus sign, but this is sum of two squares, and you cannot do that without getting imaginary numbers. And so we're going to see what happens here in a moment. I'm going to take each set of parentheses and set them equal to 0 individually. So x squared plus 4 equals 0, and then we have 2x plus 1 equals 0. I want to start on the right side first, so we're going to subtract 1 from both sides. So I get 2x equals, class is over, go Tigers. 2x equals negative 1, and then from there, we're going to divide both sides by 2. So we get that x equals a negative 1/2. So that is one root, meaning if we were to graph this, it is going to cross the x-axis when x is equal to negative 1/2, or negative 0.5. Now up here, after I subtract 4, what happens is I get a x squared equals a negative 4. So from here, to undo a square, you take the square root. When I take the square root of both sides, I should automatically remember, oh yes, I have to do plus or minus. So I'm going to get two answers, right? We get two answers from our square. So one is going to be the positive value, one's going to be the negative value. But can I take the square root of a negative number? The answer is no. So what happens is this becomes plus or minus 2i, and these are imaginary numbers. And I know what you're thinking, you're like, oh my gosh, this is why I just can't stand math, because why are these imaginary numbers? Well, this graph is going to look something like this. You know, if we have x and y, it's going to cross, where do we say, at negative 0.5, so it's going to come here, and actually, I'm sorry, that's not what it's going to look like. It's going to come here, and it's going to look like this. We're going to cross at negative 0.5, or negative 1/2. And it still is going to have that hump in it. It's just not going to cross the x-axis, but we could still find our three solutions. If I had a horizontal line, maybe like this, maybe one solution's here, another solution's there, and another solution's there. And so just because there's only one solution when x equals, or when y equals 0, it doesn't mean that there aren't other solutions elsewhere when y equals a different number. And so some of you are like, oh, imaginary numbers, why do we even learn about it? Well, because it might be imaginary when y equals 0, but it is not imaginary if y equals something else along the graph. So anyway, here are your solutions, and this is how you factor by grouping.